So when we were multiplying binomials, we ended up with a trinomial, or we call it a polynomial, which was ended up actually being a quadratic equation because it had an x squared in it. So now we're going to take those trinomials or polynomials and we're going to break them down into two binomials, or we're going to break them down. Sometimes you'll get two binomials. For the most part, I think these answers are binomials, but we will attach that as it is. I've given you a little cheat sheet, okay? And this will help you know factoring quadratics, the middle term, last term, and factors. So if your middle term is positive and your last term is positive, then that means you're going to have a positive times a positive. And you'll get this in a minute as I go over it. If your middle term is a positive, your last term is a negative, then your larger term is positive. Your larger thing that you're multiplying with is positive, and the smaller is negative. If both are negative, then you're going to have a positive here and a larger negative, and then, but I will explain this as we go and how it works, okay? So we are going to go and look at our first example. And our first example, it says, remember that trinomials come in the form of ax squared plus bx plus c. Generally, you factor the base on the value of c, okay? You find the factors of c that when multiplied make c, but when they are added together, they make b. So remember, we've got this. So here we go. We've got number one is x squared plus 5x plus 6. So we need factors that when multiplied make 6, okay? But when added make 5. And because, so I'm going to put a little chart over here for myself, and I'm going to put a 6 up here. And I'm going to look at my little chart because everything is positive. And I can zero in on this a little bit so you can see a little better. Since everything is positive, I am going to need a positive factor times a positive factor. Okay, so we need something that when multiplied, a factor times a factor equals c, all right? A factor plus a factor is going to equal b. And remember that you're looking at x squared plus bx plus c. So we're talking about c and b in this formula, or in this equation. Well, that's your 6 and your 5. All right. Right now, we don't have to worry about a because everything today, a is going to be 1. All right. So factors. I'm going to start with 1. 1 times 6 is 6, and we know they're both going to be positive. Then I can go to 2. 2 times 3 is 6. Well, when I combine 1 plus 6, I don't get 6, do I? Okay. When I do 2 plus 3, do I get 5? Yes. And 2 times 3. So that's pretty much as far as I need to go. Now, the other thing that you want to consider, sometimes right now it's not going to matter, but you want to look at what is going to be a multiple of this number and this number, which is a 1, but for us today, we're not going to be as concerned about that. Tomorrow, we'll look at that, all right? So, when I do this, I am going to break this apart, all right? And what I can do is show you this. This 5, this positive 5x is what I'm going to break apart, okay? And how I'm going to do that is I'm going to do x squared plus 2x plus 3x. So that positive 5x, I have broken down to plus 2 plus 3. Do you see that? Okay. Remember, you can do anything to an equation as long as you maintain equality. And right now, this is the same as this. Okay. So then I have plus 6. Okay. And I'm not always going to be drawing these boxes, but I want to be really dramatic with this first one to show you what I'm trying to do. So now, I compare, all right? So without the boxes, I'm going to write x squared plus 2x plus 3x plus 6. Okay? I can pair two binomials by doing this. Put my parentheses here. Okay? And I'm going to put parentheses here. Okay? I still have the same thing. Okay? So what can I factor from x squared and 2x? What can I factor out of that one? If I'm just looking at this term, what can I factor out of that term? X. So I have x times x plus 2. Okay? Then what can I factor out of here? 3. So I have plus 3, and I'm going to factor the 3 from the 3x and the 6, and I'm left with x plus 2. And the goal here is to get one binomial that is the same. Okay? So after I have that, I now can rewrite this as x plus 3. I've got this and plus 3 times x plus 2. And that is factored completely. That would be your answer. Because when I multiply those two binomials, and we're going to do a check, okay? I'm going to write over here, x plus 3 times x plus 2. And this is going to be my check, okay? X, remember FOIL, first is x times x, which is what? X squared. Then we do, what's the O? Outside. So x times 2 is plus 2x. Inside for I do 3 times x, which is a positive 3x. And then last is 3 times 2, which is plus 6. When I combine my middle terms, because those are my x's, I get x squared plus 5x plus 6. It matches, doesn't it? My original up here. And that's what the goal is. Okay? They say. Okay, let's try number 2. Okay. Y squared plus 9y plus 14. So I have a 1 over here, so we're still good with going 2 factors of 14 that when multiplied together are going to give me 14, but when added together are going to give me 9. I'm sorry, that wasn't a positive 9y, was it? It's a negative 9y. I was going to say that's never going to work. Okay? I'm very sorry about that. So, I need, according to my chart, if my middle term is negative and my last term is positive, what type of factors do I need? Negative times a negative. Negative times a negative. So both my factors are going to have to be negative. So if I use a negative 1 and a negative 14, am I going to get 9 when I add them together? No, I'm going to get what?
15.
I'm going to get positive 15, right? Okay, so then if I use let's go to 2. Negative 2 times negative 7, that does give me a positive 14. And when I combine them, do I get a negative 9? Yes? Okay, so now I know what I'm looking at. Now, to get you ready for tomorrow, I'm going to go ahead and teach you this, okay? Do you see, either way, you could put the 2 on the back turn with the 14 or the 7, and you would be able to pull something out, wouldn't you? Okay? If there's one of them that doesn't, then you don't want to do that. You want to put the one where you can pull a factor out, all right? So it's not going to matter. I'm just going to put them in order. I've got y squared minus 2y minus 7y plus 14. Do you agree that that is the same equation? Negative y is equal to these two terms, negative 2y and negative 7y. Do you agree? Okay, so all I've done is break apart the middle term. Okay, next, I'm going to pair them. Okay, and I'm going to take this in the inside, and I've got y squared minus 2y as one term plus negative 7y plus 14 as the second term. Everybody comfortable with what I've done so far? Not comfortable, but get what I'm doing. Okay? All right, so now I've got to factor the first binomial, the first term. What can I factor from that? Y. So I can pull y out, and I get y minus 2 left over. And then I have a plus. Then what do I have here?
7.
Now, I want it to end up with a negative in the middle, don't I? So it matches this binomial, y minus 2. Okay? So I'm going to take not 7 out. What am I going to take? Negative 7. And I'm going to end up with y minus 2 because 14 divided by negative 7 gives me negative 2. Okay? Now I have y minus 2. And once I get rid of those two, what's left? Times y minus 7, don't I? Because I combine what's on the outside here and what's on the outside here. Because these terms are alike. I use them here one time. So let's do the check. Y minus 2 times y minus 7. Y times y is y squared. Y times negative 7y is negative 7y. Negative 2 times y is negative 2y. Negative 2 times negative 7 is positive 14. Now I combine my like terms, y squared. A negative 7 and a negative 2 is negative 9y, and I have positive 14. And yes, that is the same as my original. I did first, outside, inside, last. I'm just not drawing all the arrows. I used FOIL. Okay? So my answer is y minus 2 times y minus 7. Any problems with what I'm doing? Kind of getting it, some of you?
Clear as mud.
Is your mind boggled, John?
Yeah.
No? How about you, Luis? You doing okay? Following? Hector? Okay, we're going to go to number 3. Okay? Number 3. Like I said, when I write a z, I always put a line in it because you do not want to get confused with a z and a 2. And it's very easy to get confused with a z and a 2. So I would highly suggest that you do that. That's an algebra thing that we do because z is used so often. So I've got z squared plus 7z minus 18. So let's see if we can deal with this. All right. So what am I trying to find factors of, Damien? What's the number that I need to find factors of?
Negative 18.
Negative 18, very good, because it is negative. I need to find factors of negative 18. Okay? So, what am I going to use? Positive, 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 negative, negative, positive, John.
Use larger positive, smaller, and times
Times
the negative.
a negative. Okay? So I know this way that my in other words, I need to end up, when I multiply a positive and a negative, I end up with a negative, don't I? Okay? And I need my larger to be positive because when I subtract or I combine a negative and a positive, I need to end up with a positive. Does that make sense to you? Okay? So if this was a negative, I'd want to end up with a negative, right? So that means the negative would have to be larger. So I'm going to start with 1, making the larger positive. So 1 times negative 18. Am I going to end up with, when I combine negative 18 and a positive 7, I know this is simple, but Luis, what am I going to end up with? If I combine them, meaning I'm putting them together. Positive 1, what am I going to end up with? Not multiplying them, combining them. Negative 17, that's not what I want. Okay? So now I'm going to use 2 times what is 18? It's 9. The 9 is larger. So I'm going to make that the negative.
Don't you want your larger to be positive?
Oh, I want my larger to be positive. Well, oh, that's right. Oh my goodness, I almost blew it. Lord have mercy. Larger to be positive. So 9 times negative 2 does give me negative 18. And a positive 9 and a negative 2 is going to give me what, Hector? A positive 9 and a negative 2. Is it going to give me negative 7 or positive 7? Nine minus 2 is what? Positive 7. Okay, so I've got what I want, right? All right, so now I'm going to pair my 9 with my 18, and I'm going to do z squared minus 2z plus 9z minus 18. And I'm doing, at this point, if I was doing this, I would be separating them like this, but I'm going to write them down one more time just to try and keep it clear for you what I've done. I'm going to pull my 2 binomials. What can I pull out of my first binomial, Brandon? Z. So I'm going to pull a z out. And that leaves me a z because z to the first, z squared divided by z to the first gives me z to the 2 minus 1. We've learned that by now, hopefully. And so then this divided by z gives me 2, negative 2. All right, and then I've got what here? Jalen, what am I going to pull out? I need to end up with a z minus 2. 9, a positive 9, yep. And I end up with z minus 2, and that's exactly what I wanted. So my 2 binomials that I'm going to write, Brandon, are going to be what?
Z minus 2 times z minus 2.
Z minus 2 times what?
Z minus 2.
Now, I have those 2 now taken care of. What?
Oh, z plus 9.
Z plus 9.
I blanked out first.
Okay. Do my check. Z minus 2 times z minus 9. I end up with z squared minus, 9. I have to put it in order. First out is negative 9z minus 2z, and last is positive 8z. Oh, I needed to make this positive. I'm bad. Oh, gosh, you guys aren't catching me because you're still thinking. I'm so sorry. Positive 18. Combine my like terms, and I end up with z. It should have been a negative 18. Oh, my goodness. Breakfast. Z squared plus 7z minus 18. And I do have a check. It does match. So that is my answer to number 3.
We're just testing you to make sure you catch your. Yeah.
That's bad. Okay. Number 4. Y squared minus 10y plus 25. So I need 2 factors of what, Kate? That when what am I going to need factors of? 25. Yep. Okay. Uh-oh. All right, and do they need to be positive, negative? What do they need to be, Hector? Positive. Positive? Both of them? Negative times negative, yep. Negative times a negative, and eventually this hopefully will come as second nature because you won't get the cheat sheet, okay? So a negative times a negative. So I'm going to start with 1 and 25. When I do that, do I get a negative 10y when I combine them? No. I'm going to go to 2. Does 2 go into 25? No. How about 3? Does 3 go into 25? No. 4 goes into 25. No. 5 goes into 25. How many times?
Negative.
5 times, so it's going to be 5 times 5, right? And they need to be negative, right? Okay. All right. So I am going to rewrite this, and it doesn't matter what order I'm using. Y squared minus 5x minus 5. I'm sorry, 5y. I'm so used to using x's. 5y. Why are my pencils breaking today? Minus 5y plus 25. So all I'm doing is rewriting that middle term as 2 terms. Okay. So I'm going to separate them into 2 binomials. What am I going to pull out of the first term, Brandon? It's all right. Y, and that leaves me y minus 5. So I need my second term to end up as y minus 5. So, Damien, what am I going to pull out of the second term?
5. Negative 5.
Negative 5, because I need to change this sign. So if I divide this by negative 5, it's going to end up positive. If I divide this by negative 5, it's going to end up negative, right? So I'm going to pull out a negative 5 times y minus 5. Okay. And I'm going to end up with what 2 terms? Jalen. Y minus 5 times what? Times y minus 5. And guess what you can call y minus 5 times y minus 5? Think about it. Think about this for a minute. And if you think you know, raise your hand. What's another way I can represent 3 times 3? Nope. 3 squared.
So y minus 5 squared.
So I can do y minus 5 squared. Same thing. What?
I said I'm just dying, and then everyone's squared.
Interesting, huh? Yeah. And they'll represent it like that for you, okay? So now you know when you have something that's this and they want the you know what that means, huh? Okay. All right, so let's check it just to be in the checking side. Y minus 5 times y minus 5, and I get y squared minus 5y minus 5y is plus 25, right? Bring them all together, I get y squared plus minus 10y plus 25. Okay? I would not spare any room. I would make sure that things are not crammed together. Some of you are still having some issues with that. And we're going to look at the next one. Because the next one is very interesting. So, number 5. Y squared minus 81. What has happened to the middle term? It disappeared, which means you had to have what to each other? It had to zero out, right? It had to cancel each other out, right? So I need two terms when multiplied together give me a negative 81, right? All right, does anybody know? Because this, and I'll teach you this trick in a minute. Okay, but for now I want to do it the long way. Negative 81, let's see. 1 times 81 ain't going to count. 1 and 81 won't cancel each other out. We know that, right? And we're going to need a positive times a negative, right? And it's going to have to be a what? What?
-9
9 times negative 9 will work, yes. So y squared plus 9y minus 9y minus 81. We can do this the really long way. Okay, we get y and we get y plus 9. And then I pull out a negative 9 and I get y plus 9. And I end up with y minus 9 times y plus 9.
Interesting.
Wait, where'd you get y minus 9?
When I pulled.
It's a negative square.
Oh, I'm sorry. Hold on here a minute. What did I do? I did it wrong in the first one. That's what changed. Ooh, good catch. Erase. Lord have mercy. And erase those because Damien caught me. You're right. If this is y plus 9y, right? Y squared plus 9y. If I pull y out, I'm going to end up with y plus 9, right? Okay. So over here, I would want to pull out a negative 9, and I end up with y plus 9, right? So now I've got y minus 9. I mean, the results are the same, but I didn't do it right. Y plus 9. Okay? So I end up with y minus 9 times y plus 9. Interesting.
You could use a negative square.
Look it. I've got a question for you. Is y squared a perfect square?
No.
Why? Why do you say no? No, it's y times y. Isn't anything times itself a perfect square? Well, especially when it's 1, because 1 is a perfect square, right? Okay, because 1 times itself only gives you 1, right? Okay, so think about 81. Is 81 a perfect square? What's the square root of 81?
9.
9 because 9 squared is 81, right? So you've got two perfect squares, and that's when this is going to cancel out in the middle. So you should get to the point that you can recognize anything with a negative is going to give you a negative and a positive in the end, and all you have to know is the square roots of both. And you've got it. It's different if it's a y squared plus 81. How would it change? A positive and a positive, wouldn't you? Yep, it would be a whole different scenario, wouldn't it? But it would be a perfect square. Interesting, huh? Yeah, okay. Interesting. Y minus 9 and y times 9. You guys, you'll get really good at these, and